Hello guys, in this video I will show you how to find the equation of a function from its graph in the case of a piecewise functions. As you remember, the piecewise functions are made of many functions. In this case we have first a line, that is this first part. So let's write that. For the line, we know that the general formula is y equals mx plus b, where m is the slope and b is the y-intercept. So let's find out those points. If you see in the graph, we can use this point and this other point. So let's find out the slope. The slope is the change on y over the change on x. The change on x for those points, that is from -4 to -2, is 2. And the change of y is from 1 to 0. So that means it's -1. So the slope is -1/2. Then we can plug in the values in this formula, that is general formula of any point. So we can use any point. In this case, I would like to use this point, that the coordinates are -2 on x, 0 on y. So we plug in here in the formula, and we say we say 0, that is the value of y, equals to m, that is -1/2, x, that is -2, plus b. So if we simplify it, we say that 0 equals -1/2 times -2 is +1 plus b. So we can say that -1 is equals to b. So already we have the values of m and b, and that means that the equation of the line is y equals m, that is -1/2, x plus b, that is -1. So here we have the equation of a line. Then we have a parabola. The parabola is the second part, this part. Even though we don't have a complete parabola, we can imagine and we can mark, as we did in the previous videos, a reference. This can be the reference. We know, well, I know that it's not part of the complete parabola. However, we're going to use that reference, even if it doesn't appear completely. So let's write it here, the parabola. First of all, for the parabola, remember the formula, and we need to find the parameters. G of x is x squared. Then we have a size of x, or now I remember that we name it x size, is equals to 2, because usually from this point to this point is 2. In this case is 4, so we are making it bigger twice. Okay, so we also have the y size, that for this parabola is 1, because usually from this point to this point is 1, and we still have 1. And finally, well, after that we have the x displacement. The x displacement for this parabola is -2, because it's the coordinate of the vertex, and the y displacement is equals to 2, because it's the coordinate of the vertex. Then we use the formula we have done before, that is y equals to the y size, that is 1, so we don't have to write it, times 1 over the x size, so 1 over 2, and we have here x minus the x displacement, that is -2, so it's x plus 2, squared, plus the y displacement, that is 2. Then remember, this squared can be applied to the 1/2, so it is 1/4, and it is also applied to the x plus 2. And now we have the canonic form of the parabola. Finally, let's find the other line that is a constant. So I'm going to write it in this space here, because we don't need a lot of space. Constant. For the constant, we know that the value is 1. So that means that the formula, let me rewrite it, is y equals 1. Now use the notation of piecewise functions, that is y equals, and we write the list of functions. In this case, the line is negative 1/2 x minus 1, comma, and we write the interval. We can notice here that the x values comes from negative infinity and arrives here to negative 2. So we are going to write that the interval is from negative infinity to negative 2. That means for values of x less than negative 2. Is it equal? Yes, it's less or equal. Why? Because here the dot here is included. So that's why we have an equal. Now let's write the second function, that is the parabola, that is 1/4 x plus 2 squared plus 2, comma, and the interval in this case is from negative 2 up to 2. Remember that we are talking about values of x. Do we include the first value? No, we don't. That's why we don't write equal. Only that x is greater than negative 2 and is less than 2. And again, is open. As you can see, we do not include that point. That's why it's not filled. I mean, that's why the circle is not filled. And finally, we write the constant, that is 1, comma, and the interval is for values of x that are greater or equal to 2. Okay guys, now here are two exercises. Please solve them, and after you solve them I will show you the answer, so pause the video. Okay, now let's start with the first one. The first one, we have a parabola first, so I will write it. We have a parabola, and remember that for the parabola we need to have a reference to know what we are manipulating. In this case I will use this part, the green part, as a reference. So from that reference we know that g of x, that is the function we are going to manipulate, is x squared. Then we know that the x size doesn't change, so it's 1 because it is the y is 2 using that reference. Then the y size is 1 because also is from 0 to 1. We have an x displacement that is negative 3 because now the vertex coordinate is negative 3, and the y coordinate of the vertex is still 0, so that's why the y displacement is 0. Then we can use the formula that we saw before, that is y equals the x size is 1, so we don't write it. We open parentheses and we write 1 over the x size, that is 1, so we don't write it again. X minus negative 3, so it's x plus 3 squared plus 0, so we don't write it again. Therefore, here we have the formula for the parabola. So let me put this formula, put it over here, and small size, the parabola. Okay. Now let's do the same, but for the second function, that is the line. The line, we have 2 points, remember, a line. For the line, we're using the formula y equals mx plus b. We need first to know the value of m, that is the change on y over the change on x. In this case, we have 2 points already, so we're going to use them. So it changed from negative 2 to 0, so the change on x is 2. And it grows from 3 to 4 on y, so that means it's 1, the change on y, so we have the slope 1/2. Then we're going to use the formula and plug in some point. We can use the point that is the y-intercept, that is 0,4. That means that the y value 4 is equals to m, that is 1/2, x, that in this case is 0, plus b. Remember that 0 times anything is 0, so we have b equals 4. And now we can write the formula, that is y equals mx 1/2 x plus b plus 4. That is the y-intercept. So here we have the formula of the second one. And finally, for the third one, we know that it's a constant, right? And the value of that constant is 2. So we're going to write it directly in the, sorry about that. we're going to write it directly, but before, let me cut this. Let's put this one over here. Okay, now let's write the formula of the piecewise function. The first function is the parabola, that is x plus 3 squared, and it is from the interval from negative infinity to negative 2. So it's for values that are less or equal to 2, because we are including the 2 in this parabola. Then we have the line that is 1/2 x plus 4, and the interval is from negative 2, sorry, it was negative 2, so it's from negative 2 to 0. So we don't include the 2 here, but we do include the 0. That's why it's filled, the circle. And finally, the constant is 2. And this value of the constant, we have it from 0 to infinity. That means for x greater than 0. We don't make it equal because we don't include it. Okay, now for the second exercise, we have also first a parabola. I have already marked the reference, that is the part in green. And for this parabola, g of x, again, is the function we are going to manipulate, that is the regular parabola, x squared. We are using the center. And the x size for this parabola is 2, because usually it's from negative 1 to 1, that is 2, and now it's 4, because it is from negative 5 to negative 1. That means that it grows twice on x. The y size is also 2. Why? Because usually it's from 0 to 1, and now it's from 0 to 2. As you can see here, it's 2, so it means it grows twice. The x displacement is equals to negative 3, because it's the vertex on x, and the y displacement is equals to 0 because it's the vertex on y. Now we can use the formula that says y equals the y size, that is 2 times 1 over the x size, times x minus the x displacement, so minus negative 3 is plus 3, and all of this squared, because we are using x squared, and plus b, so it's plus 0, so we leave it like that. We can make the simplification, that is 2. We can have the 1/2 squared, that is 1/4, and also the x plus 3 squared. That means is 2 over 4 is the same as 1/2 x plus 3 squared, and here we have the canonic form. Now, as you can see, we have the function of the line, and let's find the function of we have the function of the parabola, and now we need to find the function of the line. Let me write the formula here. And now for the line, we have already the 2 points again, and remember, the line has the formula y equals mx plus b. In this case, and in all cases on a line, m is the slope, and the slope is the change on y over the change on x. The change on y for this line is from 4 to 0, so it is negative 4, and the change on x is from negative 1 to 2, so it's 3. That means that the slope is negative 4/3. Then we plug in any point. We're going to use this point over here, that is 2, 0, right? So we write the y value, that is 0, equals to m, that is negative 4/3, times x, that is 2, times 2, plus b. We are doing this to find b. Okay, now we simplify it, so 0 is equals minus 8/3 plus b, and we know that the value of b is equals to 8/3. So we can write the equation of this line, that is y equals m x plus b, that is 8/3, and we have the formula for the line. As you can see, the constant is on 5, and I will not write that. So let's now write, let me write here the line, even smaller, okay, like this. And let me now write the formula of the piecewise function. we have a function that is made of a parabola first, and the parabola is 1/2 times x plus 3 squared, and that's for values less than 1. So from here to here we have the parabola, right? So it's for x that is less or equal to -1. Then we have the line, and the line is -4/3 x plus 8/3, and the interval is from -1 to 2, right? So we write that. Do we include the value of -1? No, that's why we don't have an equal, but we do include the value of 2. That's why we need to write here equal. And here we don't, because we don't include it. Finally, we have the constant that is 5, and we have these constants from values of x greater than 2. Do we include it? No, that's why we don't write equal, we only write greater than. Okay, so that's the answer.